For centuries, the Great Belt was not just a stretch of water on the map. It was a real barrier inside Denmark. On one side stood Zealand, home to Copenhagen and much of the country's political and economic life. On the other side lay Funen, Jutland, and the connection to mainland Europe. Anyone moving people, goods, cars, or trains between these parts of the country had to deal with the strait. Ferries made the crossing possible, but they also made it slow, weather-dependent, and limited by schedules. The Great Belt Bridge changed that. More accurately, the Great Belt Fixed Link changed it, because this project is not one single bridge. It is an 18-kilometer system of bridges, tunnel, artificial island infrastructure, roadways, and railway links designed to turn a difficult sea crossing into a predictable land route. The name Great Belt Bridge can be misleading, because people often use it to describe the entire fixed link. In reality, the system has several major parts. Between Zealand and the small island of Sprogo, road traffic crosses a huge suspension bridge, officially called the East Bridge. Trains do not use that bridge, they pass through a railway tunnel beneath the water. Then, between Sprogo and Funen, both road and rail traffic continue across the West Bridge, a long box girder bridge. This split design was not an accident. It reflected the different needs of cars, trucks, and trains, as well as the engineering challenges of crossing deep water, maintaining navigation routes, and handling harsh marine conditions in the middle of the Great Belt. The most visually dramatic part of the project is the East Bridge, the road suspension bridge between Zealand and Sprogo. Its main span is about 1.6 kilometers, placing it among the longest suspension bridge spans in the world. A span of that scale is not simply a longer version of an ordinary bridge. It must deal with wind, temperature changes, enormous cable forces, and the movement of traffic across a suspended deck. The towers rise from the sea to support massive cables, and those cables carry the deck across the main navigation channel. This allows ships to continue passing through the Great Belt while road traffic moves above them. The result is both practical infrastructure and a national landmark, visible evidence of Denmark's decision to bind its geography together with engineering. The railway solution shows how complex the project really was. Instead of sending trains over the same suspension span as road traffic, engineers routed rail traffic through a tunnel between Zealand and Sprogo. Railways have stricter requirements than roads in several ways. Trains are heavier, less flexible on gradients, and more sensitive to certain movement patterns in long suspension structures. By separating the road and rail crossings on the eastern side, the project could give each transport mode a route suited to its demands. Then, on the western side, the bridge between Sprogo and Funen could carry both road and rail traffic. This hybrid approach made the fixed link more complicated, but it also made it more functional as a permanent national transport corridor. Before the fixed link opened, the Great Belt ferries were essential to Danish transport. They carried cars, trucks, passengers, and railway traffic across the strait, forming a moving bridge made of ships. But ferry systems have limits that fixed links do not. Travelers must arrive, wait, board, cross, disembark, and continue. Freight operators must build schedules around departures. Bad weather can create delays. Even when the system works well, it inserts a pause into every journey. The Great Belt Fixed Link removed that pause. A crossing that had previously taken around an hour by ferry could now be made in roughly 10 minutes by road. That was not just a convenience. It changed how close different parts of Denmark felt to one another. The decision to build the fixed link did not come quickly. Denmark debated the idea for more than 50 years before the government finally decided in 1986 to construct it. That long debate makes sense when you consider the scale of the commitment. This was not a small regional improvement. It was the largest construction project in Danish history, with an estimated cost of 21.4 billion Danish kroner in 1988 prices, roughly 2.8 billion euros. A project of that size affects public finances, transport policy, the environment, local communities, national planning, and future economic development. The final decision represented a belief that the long-term value of permanent connection would outweigh the immense upfront cost and complexity of building across the Great Belt. Designing and building the link required major engineering and architectural coordination. The suspension bridge was designed by Danish engineering firms Cowie and Ramboll, with architectural input from Dissing plus Whiteling. The construction and assembly of the suspended deck involved Alstom Stem, with consultancy from Studio de Miranda Associati under Mario de Miranda. These names matter because megaprojects are never the work of a single designer or a single construction crew. They are systems of expertise. Structural engineers calculate forces, architects shape the visual language, marine specialists handle foundations and seabed conditions, construction teams manage assembly, and operators plan maintenance long before the first vehicles cross. The Great Belt Link is a finished object, but behind it is a vast network of technical decisions. The project opened in stages. Rail traffic began using the link in 1997, and road traffic followed in 1998. At the time, the East Bridge was one of the most impressive suspension bridges ever built. It briefly stood as the world's second-longest suspension bridge by main span, surpassed only when Japan's Akashi Kaikyo Bridge opened a few months earlier. That timing is a reminder of the global bridge-building era of the late 20th century, when countries were pushing materials, design tools, and construction methods to cross wider waterways. Denmark's achievement was not just about ranking on a list. It was about solving a national connectivity problem with a structure that could stand comparison with the most ambitious bridge projects in the world. The effect on travel was immediate and profound. Copenhagen and Zealand became more directly connected to Funen and Jutland. Freight could move more predictably. Families, commuters, tourists, and businesses no longer had to plan around a ferry bottleneck. The fixed link also became part of a larger Scandinavian and European route. Together with the Little Belt connections and the Øresund Bridge between Denmark and Sweden, the Great Belt Fixed Link helped create a continuous road and rail path from mainland Europe through Denmark and onward to Sweden. In other words, the bridge did not simply connect two Danish shores. It strengthened Denmark's role as a land bridge between continental Europe and the wider Nordic region. The economics of the link did not end when construction finished. Operation and maintenance are handled by AS Storbælt under Sund and Bælt, and the project is financed through tolls paid by vehicles and trains using the crossing. This model reflects a basic reality of large infrastructure. Building it is only the beginning. Bridges, tunnels, roadways, cables, lighting systems, safety equipment, and railway components must be inspected, repaired, cleaned, monitored, and upgraded over time. Marine environments are especially demanding, because salt, wind, moisture, and temperature shifts constantly test materials. The toll system helps fund not only repayment of construction costs, but also the ongoing work needed to keep the link safe and reliable for decades. What makes the Great Belt Fixed Link fascinating is that its importance is larger than its appearance. The suspension bridge is the icon, but the full achievement is the integration of different structures into one transport machine. A road bridge, a railway tunnel, a combined road and rail bridge, an island midpoint, navigation clearances, toll systems, safety operations, and maintenance planning all have to function together. If one part fails, the value of the whole link is affected. That is why fixed links are among the most demanding infrastructure projects a country can build. They are not just monuments of concrete and steel. They are promises of continuity, that people and goods can move predictably across geography that once interrupted them. The Great Belt Bridge matters because it turned Denmark's internal geography into a more unified network. It replaced a ferry-dependent crossing with a fast, permanent route. It reduced travel time, reshaped national mobility, supported freight and rail movement, and became part of a larger European connection toward Sweden. It also shows the trade-off at the heart of megaprojects. They require years of debate, billions in investment, complex engineering, and constant maintenance. But when they work, they change the ordinary experience of distance. A crossing that once required waiting for a ship became a 10-minute drive. That is the quiet power of infrastructure. It can make a country feel smaller, faster, and more connected without changing the map at all. If you found this helpful, please like this video and subscribe for more explainers.